Welcome to the 8th session for data visualization for the Data Science Mentor. The Data Science Mentor program is brought to you by me, Pablo. I am the founder, the convener, and the host of the Data Science Mentor program. It's an accelerated learning cohort for folks starting data science. What we aim to achieve is to help people, learners, achieve their learning goals, focus on fundamentals, and then we take it one tiny step at a time. Now, when you sign up to the Data Science Mentor, you get access to resources, the resources that we are, this learning resources, the mentorship, and then guidance. And this typically helps the learning curve. And today we are learning data visualization. And now, if this is your first session, or you're watching this as a recorded session, then it means that you have missed out on a few things. Again, it would mean that you haven't seen some of the sessions. Just to put it in perspective, you can see the letter 8, the number 8 over here, tells you that we have a first session for data visualization. Right, but that's fine. You can also, jump in, listen, and then you can keep going, and then I will always try to work out stuff as you go. Now, today we are going to be talking about plotting legends. And now for data visualization, our focus is learning to visualize data using Matplotlib, the Matplotlib data visualization tool. So that means even before, as I start, one of the first things I would write would be an import statement. So I'll import Matplotlib. .pyplot as plt, right? Additionally, I would import numpy as np, because I will use random number or random data generation to do a few things, or use numpy routines to create data for visualization. What else would I want to do? Then I would like to have a style that we're going to use, a visualization style. So to understand the visualization style, we use plt dot style. These are styles. These are it's going to be our background style. So we'll use that. Now you use plt dot style dot available, and you can use it to see all the available stuff that is here. Look at that. I haven't used this before. Let me even try out MPL gallery. What's this? So we can now come over here and we say plt dot style dot use. So this is going to be like a background, or we're going to use. I hope this is nice. So I'll run this, and yeah, so let me just put a hash here. So we just close this up. Let me see. I can make this a little large. Yes. So that's what we are. So what's up with plotting legends, right? Now, legend gives meaning to visualizations. So again, I like to just write about the intuitions here. Legends give meaning to visualization, right? So what that does is, if we put a legend, it will assign meaning to various plot elements that you have, right? So and that is very, very simple. That's basically what legends do. Now, we're just going to go on to create a very simple visual, and then see what it's like. Now I'll create X and X is going to be, I'm going to use NumPy's linspace. Again, I like to use the Shift and Tab key that shows us the documentation. It tells us that it returns evenly spaced numbers over a specified interval. So we're going to get an evenly spaced number starting from 0, right, to 10, and the size is going to be 1,000 elements. So this is the first, this is basically our data, and that's the data we're going to use to see what legends look like. So we're going to plot a legend. Now, again, I'll mention this in just about all our sessions. But there are two ways we can almost always visualize stuff. We can use plt.plot, or we can also use the object-oriented plotting technique of creating, objects first and using these objects to plot. And it depends on the way you want to use it. But at this point, I would just be doing a mix and match. Now, the first thing I'm going to do is I'm going to create a fig, which is going to be a figure, and then our axis object, right? And then we'll call this plt.subplots. Again, we can always use, you can see it's creating a figure and a set of subplots, right? And so really basic stuff here. Also, just make it a culture. Just make it a culture. Make it a norm that every time you check out stuff, every time you have a new function, try to look at what the documentation says about it. Now that's one. So now we have ax, so that means we can now do some plotting. So the first, we're going to use ax.plot, right? And we're going to call on x, which is this. We're going to call on x. Now, for x, we're going to get the sine and the cosine. So with the sine will become our x, we'll use it as either the different axes, or we'll just layer them on each other. But the whole idea is for us to see what a legend looks like. So with this, I'll just say mp.sine for x. Then there are other, at this point, if you're following from data visualization, our first session, you would realize that I'm going to use either a mix and match of line marks and colors. So over here, I'm going to have a line match with the B, and I'm going to put a label here. And then here, I'm going to call this sine. Then we have ax.plots. Again, we're going to focus on x. mp.course. And we're going to have a different stuff here. We say double dash, but we'll make this R. So we have blue and red, comma, we have a label. And we call this the cosine. Next, we're going to now say ax.axis. And at this point, when I say the axis and I write equal, then you see that at this point, there's a way we want our axis to show up. And we want when our axis to be pretty equal. So x and y axis typically going to be equal. Then our interest is, call this our legend. Our legend here, and what we're going to do is say ax.legend. So it's going to look at what we have here and get a legend. And finally, we do plt.plot, which will render, plt.show, which renders what we have. So I'll call this, and then look at it. Oh, look at what we have is it looks so small. I think I know what I have to do. It's small. So what I'm going to do is we are going to also plot and get a size for it. So let's basically get a size so that let me see if we can. Let me get a size. So I know I called fig, so I can basically call fig here, and let's see. Okay, so here's what I'm going to do. I'm going to do this. I'm going to bring this down, and I'll say fig is going to be plt dot figure. We're going to say plt dot figure, and what am I doing? So let me see. Just a bit, just a little bit, because I want to get something straight up. Okay, let's do this way. We're going to put this here, and we can now say plt dot figure, right? And plt dot figure. Then here we're going to now put big size, because I don't want that looking so small. Then we have 8 by 6. And we'll close this. Then when we come to X here, we can now say we can typically now say maybe plt dot, can we say plt dot subplot? Let's run this and see. Oh, but tuple has no. Okay, let me make this plt dot axis. Yes, plt dot axis. Yes. So you see that we have this. So basically, let me run this, and then so we can just basically get this. So yes, we have, now this looks big. So now this makes a lot of sense, right? So we typically just make changes to it so that we can have a bigger plot instead of having something small, right? I don't like the fact that it's calling it differently. What is it? Let me see if I can suppress this inline. Can I suppress this? That happens over again. Yes, just once. Yes. Okay, let me just leave this at that. So I just call it again. So we now have this, and so this is a lot better at this point, so that we can it now makes a little bit of sense for us to see what we're doing. Now at this point, you can see that we have our legend here. Now, at this point, this legend is just like a default plot for the legend, and you can see what it did, because this is our focus for today. So you can see this. But now there are other ways we can look at this legend, and we can see, okay, maybe, just maybe, we can change a bit of what it looks like. Now, we can do a bunch of things. Next is, let's come to this bottom here, and then let's see if we can customize the legend. So let's see if we can customize the legend. Now to do this, I can basically say ax.legend. I'll say axe.legend, and here with axe.legend, I can put an arbitrary number of arguments and keyword arguments. And so the first thing I want to do is I can put in location, and the location is where I want this to be. So you can see the location here is on my right hand side. I can choose that I want it to be on the left hand side, right? So I can say upper left. So this is it. Then there is, I can also choose, to basically turn on, I can choose, there's something called frame. So I can choose to put the frame on, right? Because you can see it's just over here. Nothing is around here, right? So it's basically saying, can I put something like a frame on here? Something that looks like it, like this. Right? So I put the frame equals to true, right? And then I can now call on fig. What's that? Legend or image has almost unexpected keyword arguments. Frame. Oh no. Frame on. Yep. Let's see. Oh, look at that. Now, if you pay close attention, right, you would notice that there's a frame here. There's actually a frame here, right? I don't know if maybe because of this, you might not see, but there's a frame here. How do I even ensure that you see? Just, yeah, there's a frame around here. So a frame is of this stuff. So that's, a way you can get this done. Now, again, we can think of another way to have this customized, right? And we can say, first of all, we can make them look different. And to make them look different, or to make this guy you see over here have a different feel to it, we can use something called the n call, number of columns. That means we can make them look as if they're in a column type way, right? So again, let me take this guy here and just copy this whole this and bring it over here, all in the need to customize this plot. Now, what I'm going to change here is just to let you know that there are other parameters. There's the lower left, and here we can choose to remove the frame and then introduce n call. And we can say we're going to introduce n call too. Now, I want you to pay attention to the difference here. Why do I look like this is just too big? Let's make this 6. Yes, now this looks better, right? And just this one too. Yep. Then now we can now see what this looks like. So this is not going to be at the upper left or the upper left. We're going to put it at the lower left, right? So that means it should be around here, right? And then this to be like there in the column. So if we run this, you get to see that now they are here, right? So there's stuff we can. There are lots of stuff we can do just to make it look, to customize it, right? I think this typically works. Thing to it, right? But yeah. So there are a bunch of things, but there are lots of things you can do with it. But I'll encourage you to check out the documentation and play around with it. Right now, of course, there's a default legend to it, and there are a bunch of labeled elements from which you can put in stuff. Now, what we're going to do is I'm going to try out. We can try out stuff. So we can create like a 2D line, and then you can see what it is. We've once created this before. I think we have earlier on. Sorry if the volume of the screen is too much, but we've once created this before. But just again, another way to visualize stuff, right? And now the visualization is to look at the legend. It's not the visualization, but the legend in itself. So what we want to do is we want to pass in a legend and pass in a label for the legend and say, okay, this is the way we want this to look, right? So we're going to do another generation this time. We already have our X axis. Now we're going to create our Y axis, right? And then we can now say, okay, this is where we're going to make our legend look. So here I'm going to create Y. Now with Y, I'm going to say np.sign and then open bracket X. Now, if you've done an introduction, if we looked at our introduction to NumPy, we can create a new axis, right, by using np.new axis. So what I'm going to do here is I'm going to put a square bracket, and then I'll slice it and say we have a new axis, and then we're going to say np.py. Again, these are just you will typically see a lot of these conventions that I'm using when you read books. Again, I'll almost always recommend reading the Python data science handbook, right? So if you read all this, you would see all these conventions on how to manipulate numbers using mathematical operations, right? The whole idea is just to make the data to be in a different way, shape, and form, right? So we'll have np.arange, and then here we have 0 to 2, and then 0.5. So we've had this. Okay, that works. Now we're going to create we're going to create lines. Now what I'm going to do here is I'm going to use plt.plot. Now remember that with plt.plot, how you create stuff is just typically going to now give it a sense. It's going to look at, it is going to infer what your plot will look like, because we've not determined the way the plot is going to be. So it's just typically going to look at it and say, okay, this is how it looks, right? So we say the plt.plot, and we have X, and then we have Y. We call it lines because so we've stored that in lines. So now we have X and Y axis, and they're just basically jumping over each other, right? Because sine and cosine are typically like that. That's what I wanted to show you, right? So now we can now go here and I'll say plt.legend. And here we would customize our legend, and we'll now say lines, and we typically want to make use of just look at this, just jump on this. So again, just to let you see, this is what we have as lines. Okay, I haven't called this. I have. So this is what we have as lines, or yeah. So we're typically now going to visualize this plot, this 2D plot that is here, right? So that's what I just wanted you to see. Would visualize the 2D plot. Now we will put a comma here, and so you can see when we put lines, you can see this. I'm only taking 1, and I'm going to also take 2, right? So that's just this first and second. That's what I want to take. Then for this, I'm going to say call this first line, and this is going to be like the name of the first legend, and then the second, I'm going to call it the second line. Right, and then I'm going to put a frame, just like we do frame on is equals to true, so that we can basically see that there's going to be a frame around it. We've done this, and then we can now go on to say plt.show. Right. So do we have to almost always call on this? Let's see. Let me see if I don't always have to call on this. So let me just a bit, we're just a little bit Matplotlib inline. That we can get to call on this. We mustn't always call on all this at every point. Okay. So is it because I used this and I didn't use my access? Let me call this here, and then we'll bring this over here. So at this point, what's going on? plt.figure, yes. plt.figure. I'm not supposed to be going through all this at this point. I'm surprised at why I'm having to check this. Yes, oh, can you imagine that? All right, so now we have this. So now you can see that at this point we have, we just took the first two, right? And then you can see that we now have our plot over here. We have our legend over here. And you can see that with our legend, it's here, right? And yeah, it's over here. It has the first line and the second line, right? So that's typically another way we can customize a legend. And if you pay close attention, you can see that it has like a frame on it. So that's one way we can also look at our visual. Now, an interesting thing we're going to do, which is something we haven't done, is we can decide I think we can now take like a real data, sort of something that is closer to a real data, and then try to visualize it. Right. And at this point, I'm going to share that data with you guys too. So right, so here, let me now look at what we have. Just a second. Let me be sure I have my data. Let's see, where is my data? Just a second. Let me see. At this point, I'm about Let me see if I can work out a data to use. Right. I think I see the data I'm going to use. All right. So what I'm going to do is I'm going to now I'm going to import pandas as PD. Now, first things first, I have to also get the data. So I'll call this CT underscore data. And inside I have pd.read underscore CSV. Then I have CTs. Yes, CTs. That's the data. So let's just look at what CT data looks like. CT underscore data dot head. Let's just look at the first maybe 2 rows. Look at what we have on the first 2 rows. So we have it's a city. What's this? Yeah, so at the land, so I have a feeling this should be data from a city in the US. Yeah, it's California. At the land, so a city in San Bernardino, California. Like, so this is like, yeah. Right. So next, we have a data of interest, and so what we're going to do is extract the data of interest here. Now, so what we do is we extract the data of interest, mind you, so we don't miss out on the idea. The idea is that we're going to create data, and this data we're going to look at how to set up the legends, right? And then we're trying. The whole idea is to try and see all the stuff we do regularly, because if you check maybe from 1 to 7, we almost always use generated data. So it's ideal to try it out this time around and use like data to do stuff. So that's what I'm trying to do here. If I get to have any errors, guys, just be patient with me. I'll try and see if I can sort that as we go. So extract the data. So this is the data we're interested in. So I'm going to extract. Okay, maybe we're going to extract, say, latitude and longitude data, I think. Right, we have this latitude and longitude. So we basically like maybe yeah, let's work with that. So we're going to have lat and long, and inside I'm going to say CT data, and the first thing I want to pick is going to be alt LCD, which is this, and then we're going to now have CT data for the next one here, and we're going to have long. Right, so that's this, and so we already have our data points. Now we're going to do another thing. We're going to also extract a few information, a few data that we can also use to do stuff, right? Because we have this city data, we're typically going to want to make use of, we're going to use population, and then we'll also maybe use area total square meters. So we have pop, that's what we're going to use, pop, and then we're going to use area. So in here, I'm going to say that I'm going to call on the CT data. On the CT data underscore data, right? And I'm going to take population total and just a comma again, and I'm going to call on CT data here. And real total. This. Right. Now, next is I'm going to now create scatter points. I'm going to use a scatter plot. So, and that's what I'm going to use. So here is a scatter plot. What I'm going to do here. Now, I'm going to say plt.scatter. Let it not be. Let me copy this guy here and then now introduce it over here. You know what we're looking at here. So plt.scatter, and now we already want we are going to have our long, and we're going to have our lat, and then we're going to have label equals to none. Is that it? No, let's try. Now next we're going to pick up for we're going to look at we're going to look at like markers to it. So we're going to pick out markers, and the markers we're going to pick out is we're going to say mp.log 10 on pop. So which is just going to get the logarithms of pop, right? And then we're going to now say color map. Hold on a bit. Let me see. Matplotlib color map. Matplotlib color map. Choosing a color map for Matplotlib. Aha, we can list color maps. Yeah. Now look at that. Some of the color maps here. Plasma. So we have one of this. Okay. We'll just look at them in different colors. So we can use this right. So we can have this. And then we can now say S equal to, and again, I like us to see when we take what we're taking, see S, which is going to be a marker size in points. And so our marker size is going to be our area, right? Then we are going to use line width, and our line width will be 0. And then we have alpha. Alpha tells us that we want is a level of transparency. So we can just go with a 50% transparency. And that's now, because of the way we are looking at it, we want to put other stuff into perspective. You say plt.axis. Plt.axis, we just want the axis to be equal. We want the axis to be equal. Then we have plt.xlabel. And so it's what we want to be in the X label. What's going to be on X label? Longitude and latitude. So the longitude comes first, right? So we have longitude. Then plt.y label. Of course, latitude. Yeah. Then so we have plt.color bar. Again, adds color to a plot, and we can have it typically mapped in, right? And remember here we put a color map, we put colors to this, so we can basically say, let us put our label, and our label is going to be like this. It's going to be logs. No. really interesting. Now, I have to be truthful to you all that at this point, I know that whatever is going to come out of it is going to be interesting, but I don't have the full explanation of how interesting this thing turns out, but it is interesting. So pop. Yes. Then plt dot claim again, which sets the color limit for the current image, right? And again, when we are setting the color limit, you can see we have it's either vmin or vmax. It's either vmin or vmax. If either vmin or vmax is none, the image minimum or maximum respectively will be used for color scaling. If you want to set the claim of multiple images, use scalar mappable.setClaim for this. And you can see we have from 0, we can set a bunch of things for it. So what we can do is, you know what, I'll just go with this. Let me set this. Yeah. Now the next thing we're going to do is, look, I just set some arbitrary numbers, and when we set these arbitrary numbers, they're going to come out. And when they come out, we can start to say, okay, you know what, let's chill, right? And we'll see how the color variation will go, because we are typically looking at this color here. So it's supposed to have a color variation that, you know, starts off from this thick part, right, over to this place. So we could use different colors. We could just check for plasma, inferno, and all of them. So let's see how that will be. Now we're going to create a legend. So here, this is where our legend comes in, right? So now to create a legend, we are going to write something like a very tiny for loop, right? Apologies if I'm taking so much time, but here I'm going to say for area in, and then here we're going to create, like, you know, where we're going to have it. So if there's anything within the area, I'm going to say from 100, say 300, 500. Now this is for the area. We're going to say plt dot scatter, and we'll open bracket. So we're going to have an empty bracket here, comma, another empty bracket, and we're going to say C is going to be, which is color. There's a color notation for K in terms of the, it's like, I think that's black or something like gray. And then we have an alpha, and alpha is going to be 0.3. Transparency, typically important. The color in here is going to be the area, and then the label in here is going to be the string of whatever is in the area, and now we can have plt dot legend. So we can now say plt dot legend. Look, I would have loved to copy and paste, but I just wanted us to walk through this. Hopefully at the end of it, we don't have any errors. So, and again, I want us to understand that this is typically a mixed bag of reading and a mixed bag of picking up stuff as I learn stuff and share with you guys. But I want you guys to look at it on your own and start to think, okay, after we've done all this, so verbose, right? what does this eventually show for us? We can also use it like as a standard to, create whatever it is we want to create. So let's just work with me while we're in this. Then we have city and area. Then we can now city area. Then we can now close this. Then we can now have plt dot title. And what do we call this? So we just call this cities. Cities, and we have area and population. Okay, area and population. Then right after this, we should have plt.show. What is going on here? So look at that. Okay, let us say plt.show. Right, so why do we have all these guys showing in this other anchor here? We don't have to have, why do we have this other guys showing? Okay, so but basically this is what we have here. Hold on, let me see. Yes, so you see this makes it small, right? And then if I introduce this, let me have this introduced somewhere like in here. So cities and area population. Why? Because this is unnecessary, right? Because again, okay, so again, I don't like the way this thing is popping up in here. It isn't supposed to pop up in here like this. Because this is here, but basically it's creating this guy outside this loop. That's not nice. Let me also see what happens if I run this again. So we have this. So now apparently we're not supposed to have these two guys step out of here, but there again, I'm typically having, because the first guy gets in, but the second guy doesn't. So this is 100, and these two guys are now being pulled out in a different situation, right? So area. Why is that? Okay. I again, but the whole idea is, let me see if it has to do with, it does not have to do with anything. It just basically, right, there's a bug in our code, but the interesting thing is like the visual, but basically the visual is just for us to see a bunch of things in here, right? So, but I'll try and find out why I'm having this additional stuff. Why is it coming out in such small bursts? For area and this, right? And plt.scatter. just put it's now two missing values because they're supposed to be for X and Y. Yeah. But again, it's missing two characters, and these two characters are supposed to be in our square brackets, comma, and our square brackets. So that's when it comes up. It says, oh, look at that. And because we've called it several times, right? So once we run this and we got plt.show, does that help us? Yes, we helped. So you see where I was having my issue. So it was when I called this guy in here, right? Why do I have to have this? When I called this guy in here, I was having that issue. Yes, please go ahead.
I was going to draw your attention to the dash you have inside that plt.show, but you just fixed it.
Yeah, I've removed it. So I think the bug I had was using this over here, right? But yeah, I think I have solved for that. But again, you can now see that typically we can. This is where we're looking at our legend over here in order to see this. And yes, we can now see visualizations and how. Okay, go ahead.
Sorry, I didn't get the part where you were able to fix where we were having the issue from.
Okay, this was where the issue was. If I called it in here, it typically I basically should have moved this out of here, right? Or
Okay.
what I did was if I call this with this, you see that it continuously runs this, right? So what I did was I could either bring it out here, right, and then typically see that it will not run all over anymore. But that's what I did, right? The only thing is that I just took this guy and now brought it down here. So it was the for the for loop, it was consistently, it ran a couple of times after that for loop. So what we needed to do was bring it out of the for loop, and that would typically work. So it was a for loop that had it going. So it wasn't supposed to be inside this block of code. After we had finished the visuals and having the visual object here, we just simply rendered it outside the for loop so that we don't have certain things occurring again. So and I sort of felt like one of the last, it's not like one of the last things that happened was creating of this legend. So with that plt.show, it's kept showing it over again. So this is it. So again, if you look at this legend it does not look like generic like what we had right in the other ones, because over here we created created it over here. We didn't put a frame. You can see we didn't put a frame. I can decide, okay, let's put a frame to it and make it true, and then see what it looks like when we call on a frame. And you can see that there's this weird frame that exists here, right? It does not look so intuitive, I guess. So we can just make it false, right? And yeah, you can see, so a bunch of things are happening in here, which makes this really cool. We can see that, again, we have our axis. Our axes are all equal, right? Then you can see our color mapping. We did a color mapping from here to 9, right? So these are the different color mappings that we used. We can't see some of these color mappings here. So maybe we can switch our color mapping down to, say, 7. And we'll run this and we'll see, yeah, so it's to 7. Aha, you can see that this now shows up, right? So you see this shows up here. Any other thing? You see over here for the color mapping we have here, we can come to this color maps we have here. We have plasma. Let's switch this to plasma and see how that works. See plasma, and then we run this and look at the way plasma turns out. So you can see that the color maps are here, and we can work with the different color maps we have here. Just the different moving parts that help that make us, like, you know, see all the things that's coming in handy. Now, one of the things that has often been said about Matplotlib is it's typically verbose, but the thing about it is with Matplotlib, you can manage different moving parts of your visuals. So the hope is that with this, right, I mean, we get a sense of what it feels like to use data and then do some visualization. I think it's intuitive in many ways. We have our figure here. We have our scatter plot that we wanted to build. And then we went on to look at the data we have in area. Went on to see the data we had created. Where had we created here, right? So which is this total area total here, which is the data that is over here. And then we went on to also, you know, put on a bunch of things. Depending on how we wanted the colors to look like, we checked them out using np.log for the populations here, right? And then we also used area and line widths, and we also wanted some form of transparency here. Then we went on to use plt.scatter, saying, look, we're going to scatter this based on the different kilometers per square feet in area. And then the legend was typically here. Let's look at this. We typically call a few things like how we wanted the scatter points to be. Again, different moving parts. We can just run the scatter point at 2 and see if there's been some kind of a difference. You can see where the scatter point is showing. So you see that it's important that we just basically have it as 1. Right, then we can also see label spacing as 1. Again, sometimes it's ideal to look at it and say, let's look at what label spacing is. And you can see that the spaces that have been introduced here, right? Right, so again, we can typically bring it back to 1. And all, then of course, we can see our titles here. You can see we call this the city area and all. So yeah, so that's basically what it looks like to visualize it, right? Watch this all over again. If you're watching this for the first time, please feel free to drop a comment in the comment section, or right, if you're watching a recorded session or a session that isn't live, please feel free to drop a comment in the Telegram channel or a question, and I'll definitely work with you on that. But basically, this is legend. We looked at plotting legends, customizing legends using Matplotlib.